Estimated cost concrete. This resource has been made for the external students. They do not have the face-to-face experience that internal students enjoy. By the time this is released, most students would have commenced and almost finished their attempt, but this is how I identify and estimate the concrete footings and slab. You'll also notice down the bottom here in particular, we actually have a upgrade to this particular slide and a mistake that I made in an earlier version. Okay, we have an overview of the concrete slab before we start to dissect it into sections to work out what sizes, how much concrete you have, which is really important. The other thing I have done is made a CAD drawing, and you'll notice some really key features in regards to the distance between strip footing to strip footing here to here, 2 meters and 50. The distance from this edge to this edge, 3 meters 300, and this comes into play a little bit further on when we work out the internal perimeter of each rectangle. Okay, so also we have this detail here, which is SF2, and also there is an SF1, and we'll be looking at that as well. Okay, did a little bit of drawing, and I've decided that all of the vertical strip footing beams I'm going to calculate first. And so over here, this distance, and you would need to reference your plan as well, you actually have a dimension of 10 meters and 69 from the outside to the outside of the strip footing. And so we just simply count these up. 1, 2, 3, 4. Join these two together, and we end up over here 5 at 10 meters and 69, which gives us a total of 50 meters 300. Okay, let's have a look at B. This is a little bit shorter, and when you consult your plan, you'll find that the distance from this external point to here, which is actually the veranda, is 1800. So 10 meters and 69 minus 1800 gives you 8 meters 269, and so we've got actually 16 meters 538. Okay, so when we add those two together, we actually have 66 meters 883, and we then do a formula. We've dropped the 3 off here, 66.88 times 0.3 times 0.4, and you actually have our first subtotal, which we'll be putting together right at the very end of this PowerPoint, 8.02 cubic meters. Okay, let's have a look at the next one. All right, we've got horizontal beams. And what we actually have here is, you can see that we need to calculate all of these in each and every case, and but we don't want to actually double this up. And so this is where these dimensions 2 meters and 50 come in. And so if we look at the first one over here, 8 at 2 meters and 50, you've actually got these two. And how did I get that? Basically, 5 meters is the distance from the outside of the garage walls, and we then subtract 900. Okay, so it gives us 4.1, and then we half that, 2 meters and 50 this side, 2 meters and 50 this side, and so we have 2, 4, 6, and 8. So 8 at 2 meters and 50. We then look at this center section, and we actually have 7240, and we actually subtract 600, and we end up with 3 equal spacings. Now this was done in CAD, and it's picked up a 1 mil variance, but 2 meters 214, and we actually have 9 of these. And so there you see it there. All right, each time that we're actually working these out using a highlight pen, which is as old-fashioned as estimating ever, but you need to make sure that you don't actually add anything up twice. Okay, down here we actually have another dimension, and it's 2760, and take off 600, we end up with 2160, and so we have 2 little strip footing beams there, which give us 4.32, and this is just all in lineal meters at this stage. Now we've got this little section through here, and the 300 has covered this, but it's actually 835 in between these 2 beams, and so we have 2 at 835. And then finally, last of all, we've got 1325 on your dimension on your plan layout, minus 300, which gives us 1025. So that's where all these dimensions come from. Adding them all up, you should get 43.32. All right, here's our formula. 43.32 is the lineal meter length times 0.3 by 0.4, then converts this to a cubic meter of 5.19, and this is critical. Okay, you'll notice on this slide that I've actually put some figures in here, and basically that's 2050 plus 3300 times by 2 leaves us with 10.7. Down here we've got 2600. All right, so it's a little bit different. And we've got 9.7 down here, 10.1. And so I've added these all up. You're just going to have to trust me that I got these right. And we have a look here. So we've got 2 at 10.7. Okay, we've got 2 at 9.7. There they are there. Okay, 2 at 10.1. All right, these are all the same, and we've got one over here the same. So we can actually look at this, and we've got 7 at 11.4. Okay, we've got our 1 at 900. Okay. And we've got a 7.2 just here. All right. All right, so when we calculate all these together, we end up with a total of 128.9. And the formula we use for that is we actually just form a square, 100 mil by 100 mil, so 0.1 by 0.1 divided by 2, and that gives us a figure of 0.644 of a cubic meter. And so that means that we've actually covered now all of the strip footing beams that are 300 by 400. Next slide. Okay, SF1 and SF2. So in your information, when you look under concrete and you open up the folder, you'll actually find a set of plans which actually show where SF1 and SF2 is. For whatever reason, and I have no idea why, we have this one as SF1 and then all the rest SF2. Mine's not the reason why, it's just what it is on the plan. There are no other details except for the fact it does show on one of the plans that the depth of these thickened beams is 700 deep, and it actually fits directly underneath the strip footing like this. And so when we look at this length from here to here, we only see this amount because we're looking at a plan view, but you can actually tell that this actually sits underneath here. So there's 3 dimensions, 3500, 4160, and 1575. So when we add those all up together and come through here, we've also got this distance plus these here, and we end up with 18 meters 875. All right, the same deal happens with this. You can see the beam sits underneath the strip footing. And this little fellow here does the same thing. It actually goes from here, but it finishes at this point. Okay, so it's 1800. And so there we have it, and times by 0.3 by 0.7, and we get 3.96 cubic meters of concrete. So we're rapidly actually increasing the amount of concrete, and we're actually covering each part as we go along. One of the main things that you would, if you're in an internal class, you would hear me say that we need to be methodical, and methodical is boring as hell, but at the end of the day, you would rather have that and not actually make a mistake. Now, there's half a dozen different ways that you can actually work out this particular slab. And when I did this, I chose to break this up into a square that goes right through to here, 15 meters, and 8 meters 269, which, if you remember, is our shortened beam length that runs to this edge here. Okay, so here's the formula: 15 meters by 8269, and I'm deciding to actually put the cubic meter rate there straight away. The slab is 100 mil thick, and we have 12.40 cubic, or 403 cubic meters of concrete. Now we need to subtract this little point here. 4 meters and 60 times 1.325 by 100 is 0.537 of a cubic meter. And so we actually have a cubic meter area of concrete through here, and I have not included or subtracted anything for the step down. So there it is there, and we can look at this side here. Section 1, 11.866 cubic meters. Okay, so then we're left with two sections. So we've got the garage, 5 meters by 1.8 by 100, gives us 0.9 of a cubic meter. And then we actually have section 3, 2760 by 1800 by 0.1, and we end up with 0.496. And you can see each of those amounts here, subtract, there it is there, there it is there, and there's our third section. Combined total, 13.262 cubic meters of concrete. So we're getting close. And now we've got a couple of little funny bits that we've got to work on. So let's have a look over here. And in our layout plan, now this is a Victorian plan, and they have a rebate 150 by 150, which allows 2 courses of bricks to be actually put before we actually even get to floor level. That's not what we do in South Australia, but nevertheless, we're looking at a plan, and this is a specification. So what I've done with this is basically gone around A, B, C, D, so on and so forth, all the way around the perimeter, and I've listed them here and calculated the total amount of length of the 150 by 150 rebate, and this needs to be actually subtracted from our concrete total. And so there you can see it there, comes up with a total amount of minus 1.215 cubic meters of concrete. Okay, this particular home and site is actually sitting smack dab on top of a large portion of a dam that was there that's been filled in. So this is maybe one of those blocks where the price was too good to be true. And when the engineer actually went through and worked out all the soil report and everything else like that, suddenly we have a whole heap of 450 mil piers which are going to sit in this area here. Now, roughly, the dam actually comes in And I guess the best way for me to do this is actually to grab my little pen and say, rightio, that we've actually got a dam that's going to run through long like that and down like that, approximately. And so what we have is a whole heap of beams, and in your takeoff, to sort this out to make it a little bit easier, I've actually chosen to put these totals in here, and so you've got a layout plan which actually tells you how many of these piers are 1200, and in all we've got 26 at 1.2, so that gives us 31.2 linear meters. We've got 6 at 1.8, so 1, 2, 3, 4, 5, 6, so this should have gone around there a bit. And then the remainder, you've got 12 at 3 meters. Okay, so all in all, adding up to 78.6 linear meters. Now, I've got a really handy calculator in the resources, and you can go into that, change it to metric, put in 78.6 times 450, and it will give you the answer 12.5 cubic meters of concrete. Also in that resource, if you scroll down to the round column area, it actually gives you the formula if you were using a calculator. So last of all, these are all the subtotals. So we came up with 8.02, vertical, horizontal 5.19, a chamfer 0.644, SF1 and 2 3.96, the concrete slab 13.26, less the step down minus 1.215, and then the piers 12.5, and you should come up with something pretty close to 42.35 cubic meters of concrete. Now you will find in the takeoff document that there is a proliferation of breakdowns that was put in by the student who made this takeoff, and where we have external strip footings, internal strip footings. What I want you to do is to get rid of everything else except these. So just put in one part, vertical beams, horizontal beams. Check down chamfer, that is their SF1 and 2, slab, step down, and piers. And that will be much easier for us to follow through. And I followed through last semester, the first time we used the template, and managed to actually add this twice. And so I ended up with a figure closer to 45 cubic meters, and that created, I said I knew I'd made a mistake somewhere and I couldn't find it. And so that is the reason why I've actually put together this actual presentation to assist the students on how to do this. Now, if we applied these same principles to everything that we calculate, whether we're just doing a gate, whether we're just working out the reinforcing, and we do exactly the same thing where we just calculate all the lengths and highlight each one, it will be very difficult for you to actually make a mistake. Okay, all for now.